Hi, this is Dr. Morgan over at Clovis East High School, and I'm ready to help you with the first lesson in our home study, lesson 1.1, solving multi-step equations. You notice our objective. Today we will solve multi-step equations in one variable by combining like terms and using the distributive property. Before we begin, however, I want to do a quick review on solving two-step equations, something which you should already have mastered, but in case you're still struggling, I want to go over this a little bit so that we have our basics down before we step into harder problems. So let's get started. An important concept to remember in solving any equation is the concept of equality. An equation states that two expressions are equivalent or equal. It is like a balance scale. When the weight of the items on each side of the scale is the same, then the scale is balanced and the weights are equal. So if we want to solve it, we have to always remember to keep our equation equal. In other words, the key principle, whatever you do to one side of the equation, we must do to the same thing to the other side of the equation so that the equation remains balanced. In other words, if you were just to take one or two items from the left side of the scale, then the scale would no longer be balanced. But if you took two items from the left and two items from the right, then the scale would be balanced. So we have to remember as we solve an equation, whatever we do to one side, we have to do to the other side. So remembering the concept of equality, we now have to understand that our primary goal in solving an equation is to isolate the variable. Whatever the variable is, often it's a variable like x. And what we're trying to do is to get x all by itself on one side of the equation. To demonstrate this, I'm going to use our friend Waldo. Many of you remember him as a childhood character in a book that you would try to find. But in reality, Waldo is a dangerous international drug dealer. He likes to hide out in crowds, and he's sometimes very difficult to find. Law officials would like to arrest him, but because he's so dangerous, they need to isolate him from the crowd before they can arrest him. They never know if he might be carrying a bomb on him, which he might set off and kill lots of people around him. So we don't want that to happen. So the police want to isolate him, get him all by himself before they arrest him. And so look at this following scenario. The police have identified Waldo in a building on one side of the street. They've noticed that there's three people in the building with him, and there's four people outside the building. Across the street, there's 22 people, but they're fairly safe. So what the police want to do is get everybody that's on the Waldo side of the street over to the other side of the street so they can isolate him. First thing they can do rather easily is they have the four people outside, and we usually start with those outside, and we're going to undo that. So I'm going to undo plus 4 by subtracting 4. Notice the principle of equality again. Because I took the four people away from the left side of the street, I need to do the same thing on the other side to keep the equation balanced. And so now I just have three people in the house with Waldo, and that equals 18. Now, it's a little different process to get rid of the people in the house. We just don't add or subtract them. In this case, we're going to have to divide them out of the house. The opposite of multiplying by 3 is dividing by 3. So I divide by 3 here, and 3 divided by 3 is 1. And so again, the principle of equality, I have to, if I divide one side by 3, I have to divide the other side by 3. And so as a result, Waldo equals 6. Now we have Waldo all by himself, and the police can come in and arrest him, and another case solved. We've isolated Waldo, and we have our answer. Good job. When we solve an equation, when we try to isolate a variable, we are typically using what are called inverse operations. If I want to undo addition, I use subtraction. If I want to undo subtraction, I undo addition. If I want to undo multiplication, I use division. If I want to undo division, I use multiplication. Listed below right here are the properties of equality. These basically say that if I have two expressions that are equal, if I add this, the addition property says if I add the same thing to both sides, they're still equal. The subtraction property says if I subtract the same number from both sides, the equation is still equal. Likewise, multiplication, if I multiply both sides by the same number, the equation is still equal. And division, if I divide both sides by the same number, is still equal. The only exception in division, of course, is we cannot divide by 0. There's only one person in the world who can divide by 0, and you know who that is, Chuck Norris. Let's go on. Now, when we are actually solving a two-step equation, we are actually going to undo each of the operations that's being performed in the variable. Usually that's something like a multiplication and an addition, or a multiplication and a subtraction. And in theory, it doesn't matter which operation we undo first. But in practice, it's generally easier to undo the addition or subtraction first. Kind of like the Waldo illustration. It's easier to get the people off the street first before you worry about the people in the house. If we undo multiplication or division first, we often end up with fractions and sometimes with large numbers. So usually it's a good idea to simplify using the inverse of addition or subtraction first. And then step 2, use the inverse of multiplication or division to undo that as well. Okay. You might think of it as the reverse of PEMDAS. You remember in PEMDAS, the order of operation is parentheses, exponents, multiplication, division, and then addition and subtraction. If you're solving something that way, you might do multiplication, division first, and then addition and subtraction second. But if you're undoing it, if you're solving it, think of it doing it backwards. We're going to undo addition and subtraction first, and then we're going to undo multiplication and division. And here's a quick example of a simple two-step equation. Notice the variable x is being multiplied by 2, and then the number 3 is being added to it. So we want to start by undoing the plus 3 first. Okay? So to undo plus 3, we subtract 3. And again, according to the principle of equality, we subtract 3 from both sides. So we end up with 2x equals 12. Now the x is simply being multiplied by 2. So we undo multiply by 2 by dividing by 2. And that 2 divided by 2 is 1 in this case. And that leaves us x equals 6 as our answer. If you look at it with the balanced scales here, we start off with 2x plus 3 and 15 on one side. And then we take away 3 from both sides, and notice 2x is 12, but they're still equal. We took away 3 from both sides. Now we're going to divide the 2x, so we get 1x. And that again, we're still always going to be equal. So we always do the same thing to both sides to keep them equal. Again, notice we undid the addition or subtraction first, and then the multiplication or division. We can always check out our answer in an equation. If I put the 6 back into the equation, 2 times 6 is 12 plus 3 is 15, which matches the original equation. So in this case, I know, oh, I did it right. I want to start by giving you an overview of what we're going to learn in the next 3 lessons. We're going to learn how to solve multi-step equations, not just two-step equations. And in each time, we're going to form a series of simpler equivalent equations. We're going to use the properties of equality, inverse operations, and other properties of real numbers to isolate the variable. Consider this example. In this case, I have 2 expressions that are equal to each other. When you have an expression equal to each other, that's called an equation. The first thing we want to do is to simplify each of the expressions. And we can do that on the left side and the right side using two properties. We can use the distributive property. Notice on the left side I have 3 times the quantity x plus 4. So I can use a distributive property to get rid of this grouping. So 3 times x and then 3 times 4 gives me 3 plus 12. All right. On the right side, there's no distribution needed, but I notice that I have 2 terms that have the same variable, 2x and 3x, so I could combine like terms. 2x and 3x is 5x, and now I can say 3x plus 12 equals 5x plus 8. Notice we didn't do anything from one expression to the other. We just simplified things on the left, and then we simplified things on the right. Once we get to this point, then there's a couple of steps that we want to do. The next step is we want to get all the variables on one side. It's like Waldo has a gang, and we want to get all of Waldo's gang on one side. So in this case, I can either subtract 3x from both sides and get them on the right side, or I can subtract 5x from both sides and get them on the left side. So I'm going to do 5x. All right. So if I subtract 5x from both sides again, the resulting equation is going to be equal. But notice what happens on the right when I subtract 5x, it goes away. So now I have negative 2x plus 12 equals 8. See how we've got the x on the left side now. Now, if you look at it, we just have our two-step equation that we talked about earlier. We'll undo the plus 12 by subtracting 12 from both sides. And then we'll undo the minus 2x. That's a multiplication by dividing by minus 2. Make sure when you have a minus sign that you divide by the minus sign. Minus divided by minus gets positive. And that leaves me with x equals negative 4 divided by negative 2. A negative divided by negative is a positive. So that's x equal 2. And these are the basic steps we're going to be working on in the next 3 lessons. In the first part of lesson 1.1, we want to look at how to solve equations by combining like terms. Now remember that like terms can be combined on either side of the equation, but like terms cannot be combined across the equal sign. It's like there's a wall right there. You can combine terms on the left side or you can combine terms on the right side, but you can't combine terms across the wall. For example, here I have a minus 23 on the left and a 5 on the right. I can't just say, oh, okay, minus 23 plus 5 is minus 18. That would be crossing the line. But I can combine the m's on the other side. All right. And then after you combine like terms, then we'll have a two-step equation that we'll solve as we learned above. So this is our given equation. So we've decided that we can't, the right side is already simplified. The left side, we can combine terms. So 5m plus 2m is 7m. And so my resulting equation now is 7m minus 23 equals 5. And that is a two-step equation. So like we learned above, we start by undoing the addition or subtraction. So the opposite of subtracting 23 is adding 23. So I'm going to add 23 to both sides. Remember, I can do that because the addition property of equality says if you add the same number to both sides, the equation is still valid. But when I do that, then my minus 23 is gone, and I simply have 7m equals 28. Now, the second part of our second step is to undo 7 multiplied by m. The opposite of multiplication is division. So we'll use the division property of equality that says if I divide both sides by the same number, the equation is still valid. I'll divide both sides by 7 this time because 7 divided by 7 is 1 to leave me 1m, and my answer is m equals 4. Now remember, you can always check your answers to make sure they're right by putting your answer back into the equation. So here if I put 5 times 4 minus 23 plus 2 times 4 equals 5, you see I have 20 minus 23 plus 8, and I have 5 equals 5. 20 minus 23 is negative 3. Negative 3 plus 8 is 5. And so my answer is correct. So now we're going to use the process we just described to solve problems 2, 3, and 4. And remember what the process is. First, we're going to combine like terms on the left side and right side as necessary. After that, in all 3 of these problems, you'll end up with a two-step equation that you'll solve by first adding or undoing the addition or subtraction, and then undoing the multiplication or division. Good luck. Remember the process in this problem. Combine the like terms first, then you have a two-step problem that you can solve by undoing the addition or subtraction, and then undoing the multiplication or division. The process again, combine the like terms on the right side this time. Then you have a two-step equation that you can solve by undoing the addition or subtraction, followed by undoing the multiplication or division. The second half of lesson 1.1 is solving equations using the distributive property. If you look at the equation below, you notice we have 3 times the quantity n minus 12. There's a grouping symbol, the parentheses. And part of our solution is we need to get rid of the grouping symbol. And we do that by the distributive property. So here's our equation that's given. Now, if we use the distributive property, we'll eliminate the parentheses. So we have the 3 times the n and the 3 times the minus 12. Don't lose that negative number there. It's 3 times negative 12. So we end up with 3n minus 36 equals minus 21. Now we have a two-step equation. So we undo that first by undoing the subtract 36. The opposite of subtracting 36 is adding 36. And now we're going to undo the 3 times n. The opposite of multiplying by 3 is dividing by 3. 3 divided by 3 is 1. So now I have n equals 5 as my answer. And again, I can check it out to make sure it's right. I don't have to wait to get the answers on this. I can check it out. I just put the 5 back into the original equation and see here whether it equals what the minus 21. So 3 times 5 minus 12. Well, 5 minus 12 is minus 7. 3 times minus 7 is negative 21. That's what the original equation said. So we got it right. Now we're going to use what we learned in problem 5, how to use the distributive property to solve problems 6, 7, and 8. Notice the process again. First, you will undo the grouping by using the distributive property. Then you'll have a two-step equation. You'll undo the addition or subtraction first, and then you'll undo the multiplication. Good luck. Remember our process here. First, you want to eliminate the grouping on the right side using the distributive property. Then you'll have a two-step equation, which you can solve by undoing the addition or subtraction first, and then undoing the multiplication or division. Problem 8 throws you a little bit of a curve, but nothing you can't handle. It's actually a combination of the two things we've learned this lesson. You're going to first use the distributive property to undo the 5 times the quantity n minus 2, but then notice you're going to end up with two n's on the left side, so you'll need to combine terms then, and then you'll be at a two-step and ready to finish this problem off. So let's do a quick review of what we have looked at today. First, let's do a quick review of what it means to solve a two-step equation. When we have a two-step equation like this, what operation do we do first? We usually undo the addition or subtraction. So in this case, I'm going to undo the plus 3 by subtracting 3 from both sides. Then the second step will be to undo the multiply by 2 by dividing both sides by 2. Again, remember, whatever you do to one side, you have to do to the other. And I end up with the answer x equals 6. How can I know if this answer is correct? I can check it out. I can plug it back in and see if it works. 2 times 6 plus 3, that's 12 plus 3 is 15. 15 equals 15. I got it right. So that's doing a two-step equation. What we learned in this lesson, though, was sometimes before we get to two-step, we have to simplify the expressions on either side. One way we do that is if there's any terms, like terms, that we can combine. For example, in this equation, we have an 11m and a minus 6m, so we can combine those together. I can actually move them here, you can see them easier. Then I put them together, 11m minus 6m is 5n. Now I have a two-step equation that you can solve. The other thing we have to simplify sometimes is getting rid of the groupings, and we use the distributive property to do that. If I have an equation like this, first thing I want to do is do the distributive property to get rid of the parentheses. So negative 8 times 2 is x is negative 16x, and negative 8 times negative 1. Watch this here. Don't forget the number one mistake in math classes is losing negative signs. A negative times a negative. Negative 8 times negative 1 will be positive 8, and now I can solve it. I hope this helps, and have a good evening.